All right, guys, we're moving on to the next section. So we are done with factoring and moving on to the third quadratic section, which is a focus on how to rewrite it from one form of a quadratic into another form of a quadratic. So section 2.3 is on rewriting quadratic functions. When we are done with this section, we will have a mid-unit exam. So there will be a halfway point, open-ended, let's try to apply the skills we've been working on. And I know you guys just had a skills test, and the mid-unit will be a little bit more open-ended, more application-based. So when we're rewriting, I just want to make sure we are good with our equations. So to recall standard form, I'm not going to write out all the words. I'm being a little lazy right now. We worked with standard form. We've worked with vertex form, which has our friends A, H, and K. And intercept form, which is when it's been factored. So the goal is to go from one form into another form. Sometimes that can be done in a few quick, simple steps, and other times that it takes a little bit more work to get there. And so we'll be doing this over the next couple of days. Technically, we've already gone from standard form into intercept form by factoring. So last section was a way of rewriting a function. We rewrote them from standard to intercept. The first goal of today is to get into standard form. So we will go from vertex and intercept into standard, which involves skills that you already know. It's just really distributing and combining like terms. So we're going to start off with those and do a couple quick examples. So first goal is to go from intercept form to standard form. Okay, I know this word is negatively used sometimes, but I'm going to use it right now because I personally don't mind it because it is a binomial times a binomial. We're going to FOIL first, and then we are going to distribute the A value. In those two quick steps, we will be able to get from intercept form to standard form. So we'll try two of them, do one quick together. You guys can try a second one on your own. So function is f of x equals negative times the quantity x minus 4 times the quantity 3x plus 7. So intercept form. It's already factored out for us. We got to get it back into standard form. So FOIL distributes the A. We did a lot of work with this during Unit 1 when we were multiplying functions together. So that will become 3x squared plus 7x minus 12x minus 28. If we combine the like terms here in the center, we will get 3x squared minus 5x minus 28. I'm going to put that back in parentheses because we have our A value of -1, which still has to be distributed. So if we distribute the -1, we will get negative 3x squared plus 5x plus 28, and we're going to make sure it stays in function form, so I'm going to bring back the f of x equals. And that's it. We are now in standard form. So no new skills, just using the vocabulary in a different way. And have you guys try this one on your own, so make sure you pause the video if you're watching, because I'm not going to pause, but you should try this one on your own. So we have 1/2 times x minus 8 times 2x minus 9. Your goal is to get that into standard form. I'm going to do the workout now, because hopefully you paused and already did it, so you could check your answer. We will get 2x squared. I'm focusing on distributing the two binomials at this point in time. I'm going to pause for a second because my headset's falling off right now. And then I won't be able to talk and write at the same time. Technical difficulties. here. Let's try this again. 2x squared minus 9x minus 16x plus 72. Combine like terms. We get minus 25x in the center plus 72. And then we are going to distribute the a value of 1/2. I'm going to leave anything that stays a fraction as a fraction. So we'll have half of 2x is 1x squared. Half of 25 is going to stay negative 25 halves x. And then half of 72 is 36. And bring down the f of x equals. So in this case, our b term ended up as a fraction, which is fine. We're not always going to get nice, perfect, pretty numbers. We're still going to continue with the goal of getting into standard form, but now we're going to go from vertex form to standard form. Okay. So to do this, we're going to start off by foiling the two binomials. We're going to distribute the a. So that's pretty much the same steps as intercept to standard. And then we have this last step of combining like terms with k, because we have this extra k term that we'll have to worry about at the end. That we do last. So two of these problems, I have given you f of x equals 3 times the quantity x plus 4 squared minus 9. So you might ask yourself, well, what do I got to FOIL? And in this case, we're FOILing the x plus 4. Remember, you cannot distribute exponents, this 2 right here, when there's addition and subtraction. Major math, no. So I'm going to focus on the x plus 4 squared. So I'm going to multiply it by itself. We will get x squared plus 4x plus another 4x when we do the outer and the inner, which is 8x, and then plus 16. That's going to be thrown back in the parentheses. And who are we going to be distributing? Yes, the correct answer is the a value. So we're going to distribute that a. 3x squared plus 24x plus 48. And I'm going to drop down our k value and combine that at the very end to get a final answer in standard form of 3x squared plus 24x plus 39. And that is complete. We'll do one more going from vertex to standard. You guys are going to try this on your own. So after I write it, go ahead and hit pause so you can give it a shot yourself. This one's going to be messier because I'm giving you a fractional a value, but the skill is still the same even when you're working with fractions. So you pause. I'm going to keep working through this. We're going to square our binomial to get x squared. Get a negative 6x and another negative 6x in the center to get negative 12x when we combine those terms, plus 36. Put parentheses back around that, and we're going to distribute the negative 2/3. If it helps, you can put these values over 1, and you're really multiplying the numerators and then the denominators and seeing if you can simplify those values at all. The first one is going to stay negative 2/3 x squared. Negative 2 times negative 12 is positive 24 over 3, and 24 divided by 3 is positive 8x. Then you will get negative 2 times negative 2 times positive 36, which is negative 72 over 3, because 3 times 1 is 3. And 72 divided by 3 is 24. So we will get negative 24. They came out to be whole numbers. That will not always happen. It might end up being that it stays as a fraction. I'm going to drop down our k term, which was plus 11, and combine those like terms to get our final function of negative 2/3 x squared plus 8x. And if we do negative 24 plus 11, that's going to be negative 13. Yep, just double checking my quick mental math. Even I have to think about it every once in a while to make sure I'm not giving you guys wrong answers. That's the first goal of today, going into standard form. The second goal is to learn a completely new process. So this is going to be something that you've never seen before. And the process is called completing the square. This process is going to be used to be able to write a function in vertex form from standard. So we're going backwards. We're going from standard into vertex form, which has the h and the k values in it. Before we actually do some of those examples, though, there is some formulas that we need to know to be able to use this process. Let's actually write the process down first, though. So completing the square. So it is a process used to write a quadratic from standard form into vertex form. It's going to allow you to go from standard and write that standard form equation as a perfect square trinomial, which you can easily factor into that vertex form. Okay, so when we're using this process, we're going to end up writing the trinomial into a perfect square trinomial, which I'm going to abbreviate as a PST. So we're going to end up writing the trinomial as a perfect square trinomial that we can easily factor. This process is going to involve finding a new C value. So the original C value is not going to make the problem a perfect square trinomial, so we're going to have to find a new one using this formula. B over 2 squared. So that is how we're going to find the new C value that'll turn it into a perfect square trinomial. So you'll end up with x squared plus bx plus our new C value. All right. So let's just practice using this formula first before we actually use it to rewrite an equation. So the directions, which are important to understand just as much as the process, we're going to find the value of C that makes the expression a perfect square trinomial. And then we are going to write that expression as the square of a binomial. So write that down, then I'll explain what that means. As the square of a binomial. Okay. All that last part of the directions means is factor it. Okay, because once it's a perfect square trinomial, we can factor it, and we learn that both factors are identical, so we only write it once, and then we square it, which is where the name square of a binomial comes from. It's your binomial squared, because each factor is identical. So if you wanted to put in parentheses here, this last statement really just means we're going to factor it. To write it as a square of a binomial means factor. So let's try two of these. If I gave you the expression x squared plus 10x plus c. So we don't have a c value right now. Our goal is to use the formula I just gave you to find that c value. So c is equal to b over 2 squared. So our b value is 10. divided by 2 squared. If you can do the division, you should do that first before squaring. You can't always, and that's okay. 10 divided by 2 is 5 squared, which is going to become 25. So that is the C value that makes this a perfect square trinomial. So I'm going to put that C value into the expression. So this is now a PST. So we're going to factor it, and by factoring it, we are writing it as the square of a binomial. So the square of a binomial, because both factors are identical. Recall, to do that, we square root the A and the C terms. So square root of x squared is x, square root of 25 is 5, and you take the sign of the middle. So it'll be x plus 5 squared. And we've now written it as the square of a binomial. This one I'm going to have you try on your own. You will be working with fractions, but the process is still the same. So you can pause the video and give it a shot on your own to make sure you're understanding it. But now I'm going to keep going. So to find my C, I'm going to take my B value and divide it by 2 and then square it. Now 7 divided by 2 is a decimal, and I want to leave this as a fraction. So I'm just going to square them separately. There's no addition or subtraction within the fraction, so I'm allowed to distribute my exponent. I will get positive 49 over 4. Okay, when I square negative 7, that's 49. Square 2, and I get 4. So my perfect square trinomial is x squared minus 7x plus 49 over 4. The C is always positive in a perfect square trinomial. So if you get a negative C, you probably made a mistake when you were squaring and forgot to make it into a positive. Once you got your PST, you factor it and write it as a square of a binomial. So if I square root the first and the last terms, square root of x squared is x. And when I square root this fraction, you are allowed to square root the numerator and the denominator separately. So the square root of 49 is 7, and the square root of 4 is 2. And you take the sign of the middle. You might notice a connection between this and that right there. Okay, that's not a coincidence. That will always happen, especially with these, easier to notice during these fraction ones. Now that we know how to find the C value, we can apply this to actually go from standard form into vertex form. I'm going to put the steps first, and then we can try to follow this process with two simple examples, or actually one example today, and tomorrow we'll do some that are a little bit more complicated. So we won't be able to finish it all today. So to rewrite the equation in vertex form, there's going to be 4 steps. Step number 1. We have to make the A value equal to 1. That's the first thing you do. This won't work unless our A value is 1. So for example, if the A value is 3, how could you turn it into a 1? Think about that for a second, and I'll give you the answer in a minute. You can talk about that with your partner. If the A value is 3, what would you do to it to make it a 1? And the answer is divide by 3. 3 divided by 3 is 1. But if you do it to the first term, you would have to do it to all the terms in the problem. You'll see that done tomorrow. So have to make the A value 1. That's the first step. Second step is you're going to get rid of the old C, because there's going to be a C value already, and we've got to get rid of it. So we're going to move the C value to the other side of the equation and find the new one using the formula we just practiced. The C equals B over 2 squared. Okay. That C value that you find, something that's important to remember, is you're going to add it to both sides of your equation. If you only add it to one, then it's now unbalanced and not equivalent. So once you find it, that new C is being added to both sides. Third step is to factor the PST. Because once you do step 2 and you find the C value, the trinomial should be a perfect square trinomial at the end of step 2. By finding that C value, you now have a PST. So in step 3, we can factor it and rewrite it as the square of a binomial. And the final step, at this point, we would need to re-isolate the y, because y won't be isolated anymore because of what we were doing in steps 1 and step 2. So we'll have to make sure we get the y value by itself at the end. Okay, so we're going to try an example of that. We are going from standard form into vertex form using the steps you just wrote down. So just one example today. So the original function is going to be f of x equals x squared minus 8x plus 11. That is not a perfect square trinomial. Obviously, 11 is not a perfect square. So our goal is to get it into and make it a perfect square trinomial. So step 1, make the a value 1. Do we have to do that in this example? No. A value is already 1. We're good to go. So step 1, check, finished. Step 2 says move the old c and find the new c. So this old c of 11, I'm going to subtract to the other side. So I will have f of x minus 11. I'm going to put plus blank right now. Okay, where do you think I'm putting that blank for? That's a placeholder for the new c value that we're going to find that is supposed to be added to both sides of our equation. So we're going to have x squared minus 8x plus, again, blank. So the blank we got to fill in. We move the old c, we have to find the new c. So to do that, we're going to use the formula b over 2 squared. So we will have negative 8 over 2 squared. I can do the division. I'm going to get negative 4 squared, which is positive 16. So positive 16 is being added to both sides, left side and right side. Remember, sometimes c is a fraction, so you would have to work with fractions with some of these examples. On the left-hand side, I'm going to combine like terms, so f of x and negative 11 plus 16 is positive 5 equals. And on the right side, we're going to do step 3. Because at this point in time, this is now a perfect square trinomial. You could test it to see if the b term works, but it will, as long as you did your formula for c correctly. That is a perfect square trinomial. So we can factor it into the square of a binomial. Square root of x squared is x. Square root of 16 is 4. Sign of the middle. And we're home stretch. You can see now that this is in the x minus h format. We're missing our k. So if I look on the left-hand side, I still have that plus 5 there. The y is not isolated. So we're going to subtract that 5 over to the other side. And that will give us f of x equals x minus 4 squared minus 5. And now we are in y equals a times x minus h squared plus k format, which is vertex form. There are other ways to go from standard to vertex form, but I would like you guys to practice the completing the square process, because I think it's just a good skill to have when you go on to pre-calculus. Completing the square could show up on SATs, PSATs, so it's a process that you should be familiar with, even if there are other ways to do it. So I want you to practice using this strategy, the completing the square process. Tomorrow, when we do more completing the square, the a values won't start off as 1, and we might be working with some more fractions. But that is it for today. We'll pick up tomorrow and do some more examples. And tonight you have a homework assignment mostly focused on going into standard form. So just practicing the distributing and making sure you're taking your time with that. All right. Bye, guys.